The magnet in your EV's motor weighs about 3 kilograms. It contains neodymium, dysprosium, and terbium, elements most people have never heard of. And on January 6th, Nanrus China decided Japan can't have them anymore.
This week, Bloomberg reported that China's rare earth magnet shipments to Japan fell 16% in March, hitting a 9-month low of just 6 tons. That's not a rounding error. That's a structural disruption to one of the most important manufacturing supply chains on Earth, one that runs through Japanese auto plants, Japanese defense contractors, and Japanese factories that build components for wind turbines, MRA machines, and precision-guided missiles.
The question isn't whether China's move matters. It clearly does. The question is whether Japan, a country that has been here before, has finally figured out how to survive it.
To understand why this is a crisis, you need to understand what rare earth magnets actually do. Neodymium iron boron magnets, NdFeB in shorthand, are the strongest permanent magnets known to science. They're small, they're powerful, and they're inside virtually everything that converts electricity into motion or vice versa. Your EB motor, your wind turbine generator, the servo motors in industrial robots, the actuators in fighter jet control surfaces, the guidance systems in cruise missiles.
There is no substitute. Engineers have been trying to find one for 20 years, and the honest answer from every lab is not yet, not at scale, not at cost.
China refines approximately 15 to 20% of the world's rare earth output. It produces more than 20% of the world's high-performance permanent magnets. This isn't an accident. It's the product of 4 decades of deliberate industrial policy, subsidized processing capacity, and a willingness to accept environmental costs that Western nations have not.
On January 6th, China's Ministry of Commerce announced an expansion of dual-use export controls targeting Japan specifically. The ban covers 7 medium and heavy rare earth elements, including dysprosium and terbium, the critical additives that allow magnets to function at high temperatures without losing their magnetic properties. Without Dai and TB, an EB motor in a Japanese August isn't just less efficient, it fails.
China's stated justification was Japan's evolving security posture, specifically Tokyo's public statements suggesting it might support U.S. military action in a Taiwan contingency. The message was unambiguous: Japan's foreign policy choices have supply chain consequences.
If you've been following Japan-China trade tensions, you've heard this story before. In September, 4 Chinese fishing trawler collided with Japanese Coast Guard vessels near the Senkaku Islands in the East China Sea. Japan arrested the captain. China halted rare earth exports to Japan, informally without announcement, through customs delays and paperwork obstructions that achieved the same practical effect as an embargo.
Japan panicked. Prices for dysprosium spiked more than 9% in 18 months. Automakers scrambled. The episode became a case study in supply chain vulnerability, proof that a single country could hold an entire industrial sector hostage through control of materials that most people had never heard of.
Japan responded. It spent the next decade building strategic stockpiles, today estimated at roughly Luke's days of consumption, diversifying sourcing, and funding research into magnet alternatives. When China moved in January, RCL, Japan wasn't caught completely flat-footed.
But Liu's days buys you time. It doesn't buy you independence. The production data tells the story. Japan-based Proterial, the world's leading producer of sintered NdFeB magnets, operates Nissan Japan-based Proterial, the world's leading producer of sintered NdFeB magnets, operates Nissan Subaru and Suzuki. Both companies depend on Chinese supplies of the raw oxides and metals that their Japanese factories then process into finished magnets.
The restrictions are already biting. Suzuki suspended production of its Swift model, Japan's best-selling compact car in certain months, citing rare earth supply disruption. Nissan has reported similar pressures. Toyota for now has remained quiet, but the company's dependence on proterial magnets for its hybrid and EV drivetrains makes it the most exposed of the three.
Here is where the story gets genuinely interesting, because Japan's response has not been to panic. It's been to execute a strategy that's been years in preparation, accelerated now by necessity.
The Deep Sea Gambit. In late January, Nissan, a Japanese research vessel, began the world's first continuous extraction test of rare earth mud from the Pacific seabed near Minamitori Island, approximately 10 kilometers southeast of Tokyo. The target depth, 10 meters. The asset, a deposit identified by a University of Tokyo team containing an estimated 3 million tons of rare earth mud, including high concentrations of yttrium, which is critical for phosphors and lasers, and dysprosium, the exact element China just embargoed.
In February, the vessel successfully retrieved its first batch of sediment. Japan's New Energy and Industrial Technology Development Organization plans to build a dedicated processing facility on Minamitorishima by Nissan Tantain. If the engineering works at scale, still a very large if, Japan would control a rare earth reserve potentially larger than anything outside China.
The alliance play. Japan has spent the past 18 months signing critical mineral agreements with countries that can offer what China cannot: predictable supply with no geopolitical strings attached.
Australia's Lynas Rare Earths, the only significant rare earth producer outside China, has agreed to allocate 50% of its heavy rare earth oxide output to Japan. Japan-Australia Rare Earths, the joint venture co-owned by Sojitz and the government-backed JOGMEC, is the vehicle. This matters because heavy rare earths, dysprosium, terbium, holmium, are exactly what China just restricted.
Brazil holds the world's second largest rare earth reserves, approximately 30 million metric tons. A major mine in the state of Goiás began commercial operations in Shin-Etsu, and Japan has been positioning itself as a priority customer since the beginning. A Japan-France joint refining project in Europe rounds out a diversification picture that, taken together, starts to look like a coherent strategy rather than a collection of desperate bets.
The U.S. anchor. On March 19, Japan and the United States signed a formal framework for critical mineral supply chain cooperation, the operational successor to an October Nissan-Arsawu agreement signed by Prime Minister Takaichi and President Trump. The initiative involves 4 specific U.S.-based projects, with Mitsubishi Materials and Mitsui & Co. providing Japanese industrial capacity. Projects span rare earth refining in Indiana, lithium mining in North Carolina with Albemarle, and a major copper development in Arizona. There is also preliminary discussion of cooperation on seabed resources near Hawaii, a nod to Japan's Minamitori ambitions.
The technology hedge. Proterial has quietly launched a mass production line for dysprosium and terbium-free magnets, a formulation that sacrifices some high-temperature performance for supply chain independence. It's not a perfect substitute, but for applications where the thermal demands are lower, certain home appliances, smaller motors, some robotics, it changes the calculus. TDK is running parallel research. The goal isn't to eliminate rare earth dependence, it's to shrink the surface area of vulnerability.
Here is what China's move reveals about Japan that most coverage misses. Japan is not the passive, consensus-bound economy that some Western analysts still imagine it to be. The response to the January ASEAN Airsluk export controls, deep-sea mining tests, alliance building across 4 continents, technology investment in next-generation magnets, a formal U.S. partnership,
represents coordinated strategic action at a speed that would have been unrecognizable 20 years ago.
It also reveals the limits of the weaponization strategy. China's leverage depends on Japan having nowhere else to go. Japan has spent a decade making sure that is not true, at least not permanently.
The honest assessment is that this is a crisis in slow motion rather than an emergency. Japan's 60-day stockpile is being drawn down. The alternative supply chains are real but not yet at scale. The deep-sea mining technology is promising but unproven commercially. The gap between where Japan is today and where it needs to be is measured in years, not months.
But China's weapon, once used, has a limited shelf life. Every shipment Japan doesn't receive from China is a calculation that pushes Japanese procurement further toward Australia, Brazil, and the seafloor. The January Norsiri controls may prove to be the moment China's rare earth leverage began to expire, not because Japan got lucky, but because Japan chose to spend 2 decades getting ready.
The magnet in your EB motor still probably came from China. By Risen Saj. The odds on that bet look considerably different. Word count. Sen Yuhach Nunsub words estimated duration. Ris minutes. Format news flash.